All right, we're going to go ahead and get rolling. We've got lots of ground to cover, and I want this to be a bit of an interactive workshop, so it's a little bit strange. Normally I do these workshops in person. The last one I did was kind of the first stage of this series, was building a workshop, and I did that in San Francisco a few months ago in person at the Cloudflare offices. So this is kind of the second part to that, and we're all doing it remotely now. But I do like to try and keep it interactive, so there will be a couple of times opportunities for questions. So as things don't make sense, it's a little bit hard for me staring at a computer screen and not being able to read facial expressions to know when I've lost you. So be sure and keep questions in mind. I'll try and remember to take breaks for you to ask the questions that you have. This is a technical workshop. This isn't going over just the features or what Stellar is. We're going to be jumping into some JavaScript code and spending a lot of our time actually going through how you would implement SEP-24 into a wallet. So hopefully we have some technical savvy folks in here. If you're not, don't worry. You're more than welcome to stick around and enjoy the actual coding process for building front-end applications on Stellar. But I'm going to do my best to try and keep this a little bit interactive, so keep those unmute buttons ready. But when you're not talking, make sure you stay muted unless we're already locked in like a walkie-talkie version. Sounds fine for me so far. So here we go. SEP-24 workshop. It's the concept of interactive deposit and withdrawals on Stellar. We'll get into that in just a minute. My name is Tyler Vanderhoeven. I'm the ecosystem evangelist at the Stellar Development Foundation, basically spending my time doing workshops like this, writing documentation, tutorials, lots of little example web apps and code snippets for people to get started and jumpstart development on Stellar. I also help manage the Stellar Community Fund, which is a grant program that runs quarterly, where we give out 3 million lumens to 8 different projects, or split that 3 million lumens up amongst 8 different projects every quarter. So as you have great ideas to build on Stellar, be sure and check out communityfund.stellar.org to get a better sense of what that is and if it might be a good fit for the projects that you're working on. I think a good place to start here is just describing what a SEP is. For those who maybe either aren't familiar with Stellar or aren't familiar with SEPs and caps within Stellar, it's important to understand what these are. So when you have this open protocol, particularly an open financial protocol, where lots of different entities and companies are building on top of it, it very quickly becomes apparent that there needs to be some sort of both upgrade method as well as some consensus around how to accomplish similar tasks or goals. So as you're building a fintech application, you're going to run up against problems that every other company who builds, or at least many companies that build on top of the same platform are going to have. And SEPs is how we all come to some sort of agreement on how to address those problems. So to read it out, a SEP is simply an abbreviation of Stellar Ecosystem Proposal, designed to create cohesion around specific use cases and interactions within the ecosystem with the end goal of global interoperability. So again, the idea of we're all going to be facing similar problems. What are the best ways, the ways to address those problems so that as we solve them, we have implementations or solutions which are all the same, so we create interoperability where our services can interact with one another because we've all done the same thing. More simply, an SEP, a SEP, is a statement of agreement on how to accomplish shared tasks. So what is SEP-24? We have quite a few SEPs right now, so you can comb those. I'll jump over to my browser in a minute and look through SEP-24, the actual repository for that. But there's lots of different SEPs out there. They are community driven and community discussed, and they have different phases between drafts and review and active, etc. But SEP-24, to steal their description from the repository, this SEP defines a standard way for anchors and wallets to interact on behalf of users. This improves user experience by allowing wallets and other clients to interact with anchors directly without the user needing to leave the wallet to go to the Anchor's site. It is based on SEP-6, which is kind of the first version of SEP-24, but only supports the interactive flow. So that flow that kind of shows a piece of the Anchor site, but in like an iframe or something. The interactive flow and cleans up or removes confusing artifacts. So it's kind of like an upgrade or the second version of SEP-6. So this would be the more common SEP that you're going to approach when you're interacting with anchors, which begs the obvious question, what is an anchor? Again, to steal from our description on stellar.org of what an anchor is, Stellar anchors are the on and off ramps of the Stellar network. They accept deposits of fiat currencies, such as USD, CNY, and BRL, via existing rails, such as bank deposits or cash-in points, and send a user the equivalent digital tokens representing those deposits on the Stellar network. On the flip side, kind of vice versa, they allow holders to redeem those tokens for real-world assets they represent. So in short, they allow you to take your Chase Bank dollars, your physical cash bank dollars, and tokenize them. This is a service that allows those to be tokenized and moved into the Stellar network and vice versa. Take tokens from the Stellar network, go through an anchor, and have that money delivered into a bank account. Stellar is not replacing or it is not itself a bank. It is a convener, a connector of existing financial architecture all over the world into a digital network where that value can interact with each other. And that's where the SEP becomes very important, because if we had a different way of tokenizing and getting money in and out of the network, and it was a bunch of different ways to do it, there would be very little to no interoperability where those tokens couldn't play with each other, they couldn't interact with each other. You would have to have a unique interface and interaction for every single anchor. So if you had US dollar, you'd have to use one API. If you had euros, you'd have to have another API. If you had Brazilian real, you'd have to have another API. And so rather than having all of these different interfaces and APIs, we've come up with SEP-24. The community has decided on an API interface, singular ones, like here's how we're going to get this done. Here's how we're going to get money from the real world, traditional financial architecture, this existing rails. Here's how we're going to get it into Stellar across the board, no matter where you are, so that we have one API that we implement into a wallet, or we build out as an anchor service ourselves, so that everybody is on the same page, and we create a tremendous amount of interoperability and ease of use when either building or interacting with Stellar. So that's all my slides, because this is a coding workshop. So we are going to, first let's look a little bit at our repositories, both for our demo wallet that we're going to be looking at, as well as this SEP-24 repository. And I've got a nice little tab up here, so I think I'm just going to expand this and then shrink that below that tab so I don't accidentally stop sharing. Maybe before we move in, does anybody have any questions for me regarding what we've gone through so far? Anything that's not quite clear that could use a little clarification before we start digging into repositories and code? No? Perfect. Don't be shy. I don't bite. It's all digital, so I'm unable to. So if you have questions for me, be sure and ask those when you have opportunity. And if something is really unclear or super incorrect, I know there's a couple of other of my colleagues, SDF members in here, be sure and interrupt me if I get something wrong, and it would be helpful to clarify anything that I've said. Okay, let's jump into our repository. So we're going to be working in this Stellar demo wallet repository. So this is an open source wallet, kind of a reference demo wallet. As I mentioned, I did a workshop a few months ago where we built out the core of this. And so we're kind of going to be building on top of that. It's going to be follow along, but you don't have to worry about coding anything today. You can just kind of follow along. And then this is a recording, obviously, so you can walk back through it if you need to kind of get back up to speed and practice implementing this SEP-24. But for our purposes today, we're not going to be spending a whole lot of time coding from ground zero. We're going to move up kind of what we finished with in the last workshop and build on that, the additional functionality of this on and off ramp. If you want, actually it's this one right here, you can begin to interact with this. I would encourage you to load this up, but don't play with it yet so we don't get too distracted. stellar-demo-wallet.now.sh, which is extremely long, so I'm going to pop that into the chat so that is a clickable link for everyone. But we'll be able to play with what I'm building yourselves, or you can, of course, clone this repository and get it running on your machine if that's the way you want to run it as well. So you can actually experiment with some code, depends on your level of comfort there. But this demo wallet is up and running at this URL if you want to play with it. And now let's look at our SEP-24. So inside of this Stellar protocol repository, we have all of the core and ecosystem proposals. So CAPS, core advancement proposals, are actual updates to core itself. So adding additional functionality to the Stellar program, the engine that is Stellar. And then there are ecosystem proposals, which aren't updates to programs necessarily. They're just agreements on how we're going to implement Stellar to solve different problems. So there's going to be some pretty big differences there, but for our purposes, we are in ecosystem and we are in SEP-24. Interactive Anchor Wallet Asset Transfer Server. And it's quite a big one. Not all SEPs are quite this long. They tend to be longer, obviously, if we're implementing something that's very essential and large and widespread across the ecosystem. You have to make sure you get it right and slowly over time include enough functionality and features to cover the use case. They tend to be very focused. SEPs tend to be very focused on a very specific use case, in this case on and off ramps, but that is a very big topic. So it is quite a long proposal. Obviously it's not massive, so you'll definitely be able to figure it out for the kinds of things that it allows you to do. It's not too huge. We really only have a few endpoints. So in this case, this SEP is how to build or run an Anchor server. This would be if you wanted to create an Anchor server. These would be the endpoints that you're going to need to implement. But on the flip side, as a wallet, these are the endpoints that you'll need to use to interact with an Anchor. It may not necessarily cover all of the, if you're implementing an Anchor, it may not cover all of the, legal liabilities and how to actually create assets and stuff, but it would really be how to interact from a wallet side with an Anchor server.
Hey, Tyler.
Yeah, go ahead.
Can you quickly explain the difference between SEP-24 and something like SEP-31 and kind of what the difference is there?
Sure. I'm not super familiar with SEP-31, but I know it's something to do with direct payments. So I think this is going to be more payments. I'm honestly not super familiar with this SEP. This one's quite new.
Okay, no worries.
If you know more and you're just triggering or you're queuing me up to try and explain that, if you understand SEP-31 a bit more, that would be helpful to be able to explain how it's different from SEP-24.
Yeah, sure. So SEP-24 is for a single person, like it's for somebody who wants to take their money and put it on the Stellar network, or take their Stellar money and take it off the Stellar network and get fiat money. But SEP-31 is like a payment SEP. So the idea is that you would give your money to some Anchor, and that Anchor would send your money to somebody else and deposit it into their bank account.
Ah, interesting.
So, yeah.
So it would kind of be like the payment side. So if Anchor's kind of sitting in the middle and then you have payments on both sides, this would be all three of those things kind of put together, where you've got the payment that I assume interacts with Anchor in some way that then finishes that payment. It's like a remittance SEP almost, where the payment is all made seamlessly without you necessarily having to create those flows and payments yourself.
Yeah, so like the person doesn't this person sending the money and the person receiving the money may not even know that the anchors are using Stellar. They just do the transaction and then facilitate the on and off ramps, similar to how SEP-24 does it. But once it gets on the network, it's sent over and then immediately withdrawn, right?
Yeah, that's super cool. So in the SEP-24 case, which what we'll see today is when you pull out, you're essentially going to make a deposit, which you'll put your fiat money in, and it'll get tokenized and put into your wallet. But then if you actually want to use that, you're going to go and need to make a payment to somebody, and then they have to take that money and then do the inverse through whatever anchor they have to withdraw it. Whereas this step is kind of packaging all those steps into one thing.
Exactly.
Awesome. Well, we'll have to do a follow-up on SEP-31. But I do think it's important to understand SEP-24 because SEP-31 is a very valuable use case, it sounds like, but also having control over the individual pieces is also very important, to where you can simply do a withdrawal and deposit from your own account without necessarily having to also attach that to a subsequent payment to an individual or entity. So back to our SEP-24 with our individual endpoints. As you implement SEP-24, really any SEP, you'll look through the documentation here, and we find our API endpoints that we're going to use to interact with the anchors. And before, I guess, as I start to program this, it's worth calling out that Stellar has SDF has a demo anchor server that we run ourselves, but is also a really good boilerplate to begin to set up your own anchor server. So Jake, the guy who's just talking, he's a big contributor to this. He runs a lot of this. So he's done a really good job kind of bootstrapping how the anchor side of this works. And so we're going to be using the anchor server that they've set up so that we can interact on the test net with an actual anchor to get a feel for what it would be like to interact with a live anchor server. One of the reasons that testing can be kind of tricky is that you are dealing with a real world bank infrastructure. And so if you're trying to do deposits and withdrawals, that can take 7 days for your money to go from your bank to the anchor to a token. And that's not very conducive to doing development. So being able to kind of fake these things in a development environment through this Polaris test anchor server is going to be very beneficial and help you a lot when you start to integrate your own, if you're building out a wallet or a service that integrates with anchors, to have a testing platform where they've got a URL, which we'll look at in a minute, to actually ping and grab information from. All right, and then we have our Stellar docs. So if you go to developers.stellar.org, we've got some brand new docs, /docs, where we can poke around, particularly with the deposit and withdraw documents, which kind of explains a bit more of the anchor flow and how you would set up an anchor service, as well as the one that I wrote, which is this wallet tutorial. So this kind of goes through all of the steps, some of which we'll be covering today. So as you need to get up to speed or just need a written version of this, developers.stellar.org/docs, build apps overview and enable deposit and withdraw overview. Those would be the good places to get started on this. All right, so do we have any follow-up questions before we jump into code? Okie dokie. Oh, this is super tiny. Oh, we got questions. I hear a mic somewhere. Maybe not. All right, so in the code here, and this again is coming from the Stellar demo wallet. So we download that, and this is what we're going to be working off, the master branch here. There's a bunch of different branches that will correlate to different stages in this build a wallet, build apps section of the docs. But the branch we'll be working in today is master, which kind of just has everything. So let's just kind of walk through a little bit of this project setup. This is a Stencil.js web component. If you've heard of Svelte, or I think React might have some web components now. It's essentially a very modular web component that you can just kind of plug in anywhere. You build a very nice modular little web app. In this case, it's just a little component that will have all the functionality needed to interact with the Stellar network as a wallet. And I think it's worth, so the original talk there, I guess the first talk I do in this series goes through in detail what a wallet is. And I think it's maybe worth kind of going back a little bit to describe a wallet. When I say wallet, I don't necessarily mean an interface that allows you to do trading and see markets and even necessarily make payments. A wallet is simply, at the end of the day, it's just a method or a device that allows you to store and make use of your secret key. So everything within cryptography, within Stellar, boils back to the ability to have and use a Stellar account, which is that key or address that you can begin to use to accept and send payments and do all the things that Stellar can do. And a wallet is your interface into how to interact with that. So it's helpful to not think of wallets necessarily always being, StellarX or Lobster or Satoshi Pay. It can be a lot. It can be a lot of different things. If you have a game and you're using wallets, or if you're using addresses, you're going to have some wallet aspect. If you are building any sort of financial interface that is making use of Stellar addresses and Stellar keys, even if those aren't necessarily surfaced, but if you're making use of storing and utilizing keys, you are technically a wallet. And so when I say wallet, I'm kind of using those terms of there's going to be keys that are being used to do things. So you may think, oh, I'm not a wallet, this isn't for me. If you're using Stellar, you probably at some level are either a wallet or you're going to be interfacing using a wallet. So all of these functions and code snippets and functionalities we'll be covering today or have covered in the past in this series, while they are targeted wallets, my definition of wallet is perhaps a bit narrower or more specific to kind of any method by which you store and use secret keys. So this again is a Stencil project. We've got everything kind of boils out of this source directory. We won't get in too much. Basically, I mean, if you've done any programming with modern web development, you probably are familiar with this kind of single page application structure where everything tends to start boiling out of a single entry point. And then you just start creating some sort of structure where you've got some global scope type stuff and some outside services which you'll implement and import into other components or pages or whatever. And so most of our work is not going to be in either of those. It's going to be in this component wallet directory. We've got a loader, which is just like a spinner for making it obvious that something is happening, and then a prompt, which is basically just a pop-up. So those aren't really wallet specific at all. Everything else that's wallet specific is happening inside of the wallet directory. And then we've got kind of our starter point. So everything is just being imported and queued up inside of this wallet file, wallet class. And then that just imports a whole bunch of methods, which is this right here. So in the last talk, we go over a lot of these other simple functions like creating an account and making payments and copying your secret seed and stuff like that, which I'll go through in just a minute, not the code for it, but the usage of those, just so you can kind of get up to speed. But what we're going to be interested in today is our deposit asset and withdrawal asset. So at this point, I'm going to open up my wallet. So I've got this running just npm start, which spins it up at localhost port 3333. And then we are going to create an account. And I'm going to pull up my local storage and session storage. So when we create an account, I'm going to give it a very short little PIN code. This is what we're using to encrypt the secret seed browser side. There's no server on this application. It's all stored in localhost. And I'm also going to save this PIN code in my session, just so I don't have to re-enter this PIN code a whole bunch for this demo. So we're just going to store it. 1, 2, 3, 4. Whoops, just gave away my PIN code. That's going to encrypt that and put it into local storage, which we can see right here, this encrypted key store. And then the session, 1, 2, 3, 4 is the PIN code. And so that's what we'll use to access our wallet. There are lots of different ways to do key storage, and our wallet SDK has a really good method for a couple of different methods for doing that. You have the choice between being a custodial wallet where you hold the secret keys, and a non-custodial where you delegate that security out to your users. With our most recent SEP, or one of our more recent SEPs, SEP-31, I think it's SEP-30. Wait, we have the account recovery, which allows you to kind of be in the middle. That was SEP-31 that we just talked about. SEP-30, which is the recovery signer. So this ability to split a key recovery up amongst multiple parties. So you can hold a non-custodian stance with your wallet, but also allow users to not bear the burden of all of this sort of security. Like if you lose your mnemonic phrase, you're donezo. So if you kind of want a native, I guess if you want a very user-friendly experience while also not being a custodial wallet, SEP-30 may be a really good place for you to look into. But again, a little bit outside of what we're talking about today. But another SEP that sort of says, how are we going to handle a very usable wallet, but also a non-custodial wallet where we're not liable for holding all of our users' secret keys. All right, so we've loaded up our initial wallet. FriendBot gives us 10,000 lumens. This is all running on testnet. If we were to pop this into our lumen scan, where's our search bar? There it is. We see we've got our 10,000 lumens. Nothing's really happened on this account yet, other than being created. We got that popped in. Copy address, obviously just copies the address. Secrecy is going to do the same thing, and since we have the PIN code stored in our session, we don't have to ask for that again. If I were to real quick close this session out and open it again, and we try and copy the secret, it's going to ask me for that PIN code again. And if we don't store it, it'll ask it every time. So I'm going to make sure we store that so we don't have to keep entering it. We got some details down here that we can pop open to show just the account state and all the different aspects and available values inside of our account. Won't get into too many of these today, but it's there to show particularly like balances and any additional signers we might have had. Got a raw update account, which basically just calls the ledger, the Stellar Horizon endpoint to say, hey, look up this account, what's the state, and then we'll update the details page. This function method gets called automatically on most of these interactions, so we actually don't need to click that too often, but if something gets stuck, sometimes that's a nice button to have. We have a payment button here, which just makes a payment. We can select different assets if we have any, but right now we just have XLM, so we can make a payment to somebody. If we need to add a trust line to accept custom assets, we've got a method to do that as well, which we actually use in our deposit and withdraw asset. So this is what we're focused on today, the deposit asset and the withdraw asset. Any questions now that we've kind of gone over the overview and are ready to start diving into implementing SEP-24? All right, super. So we're going to start with deposit asset, obviously, because we can't withdraw something that we don't have. So the first step to getting an asset into our account. So from our bank account, into the Stellar network. That would be our deposit flow. So if we were to go to our, looks like I closed it. Let me just pop that back open again. We've got some different endpoints here, and one of those is for deposit. But I'm just going to start walking through, we got deposit and withdrawal. I'm just going to start walking through this code here and then pop back and forth between the SEP docs and the actual implementation of the docs. So the first thing when we're setting up, so this is the method that is fired whenever we click this button, deposit asset. It's going to open a prompt. It's going to look at the currencies. Now this is coming from a TOML file, which this TOML file would be when an entity sets up, like, they're like, I'm going to be an anchor. They're going to have a domain, myanchor.com, and at a specific route on that domain, you will store a TOML file. And in our case, that TOML file, I think, is coming from a component will load maybe the, well, here, right here, test anchor stellar.org. So that's our domain, and the TOML file address for that is, if we want to look this up, .well-known stellar.toml. So .well-known/stellar.toml. So this is the location where information about this anchor is stored, or really this Stellar entity. Any Stellar entity that wants to provide a service on the Stellar network should have a stellar.toml file, particularly if you're doing any sort of asset issuance. So that's another SEP. If we were to go to SEP-1, this is where the Stellar TOML file is declared, and all the different endpoints that are keys that are available in that. So this is going to be another one that when somebody sets up a TOML file, there's all the different keys that are available to put inside a Stellar TOML file, where everybody can say, okay, if we're going to set up a Stellar account or a Stellar entity, what's our KYC server? What's our web auth endpoint? So that there's some consensus on where those things exist and where to get information about those. And so it kind of serves as a hub from which all other services that you might provide is going to flow out of. So we've got this TOML file, and inside that TOML file, specific to our purposes today, is SEP-24 transfer server endpoint. So if we look up our Stellar TOML file, we'll have this endpoint. And I think we're going to be using a couple of these. If we go back to our TOML file, the first one we're actually looking up is currencies. And so that's going to be inside this array right here. And so it's going to have an array of currencies. And one of those is this SRT asset. And so if we go back to our code, we are setting up a prompt with an options selection set to the array of currencies. And you can see, in fact, we do have that. There's the one currency there, SRT, and we'll hit OK. That's the currency that I'm going to want to deposit. Now it's going to trigger off a whole load of things that we'll get into here in just a minute. So that's going to set the currency. We're going to look for the PIN code. We already have the PIN code put in our session. So when we set the prompt, it's going to go ahead and realize, oh, you've already got the PIN code, so it'll automatically fill that in. It will get from the PIN code the actual value from that. So this is some of the security stuff that's involved with how that PIN code is used. We don't use the raw PIN code. We use a stretched PIN code so that the PIN code can be short, but the way it's used in generating the encryption for the key is actually longer than the PIN code. And then we get our balances. So this is going to look at our existing account. So when we load up our details here, I'm going to refresh this so we don't have this pending anchor piece. we can see the balances that we've set. So I'm actually going to get a new account because we've gone a little bit too far automatically. A lot of stuff happens in the background to make things easier, but it's going faster than I'm able to explain it. So in our balances, we just have lumens right now, this native asset, lumens, XLM, and we're going to need to add to that. So this essentially is looking at the balance and asking the question, does it have the currency that we're asking for? So when we deposit SRT, do we already have a trust line issued for SRT? Because payment can't be made to us unless we've trusted this asset. So if we don't have this currency, this SRT currency trusted in our account yet, go ahead and issue the trust line for it. So it's going to use this trust asset method in the background to go ahead and add that trust line to our account so that we're able to receive this SRT token once we make a deposit for it. The next thing that triggers off automatically after that is this transfer server info. So if we go back to our SEP-24, we can see our info right here. So this is going to have lots of information about the actual available options within this particular anchor. So the currencies that they offer, whether or not they're enabled, the fees that they have, the min and max amounts that you're able to deposit and withdraw. Lots of information that will feed into any interface. Like if you, I don't right now in this demo, but if you wanted to show, when you select SRT, you could call that info endpoint and show some information about min and max deposits that may help the user decide whether or not they want to hit OK, continue with the flow or not. So any information that's relevant to the anchor service itself is going to be listed in this info endpoint. So we go ahead and call that, and we load it into this variable info, which we can make use of in the future. I don't actually think we're doing much with this info endpoint in this flow, but if you need it, it's there to provide more insight into what services the anchor provides, which you could then bubble back to the actual interface as needed. The next step, to be able to actually interact with the anchor, you're going to need to prove your identity. You need to prove ownership over the account in question. So you don't want to be depositing money into an account that a user doesn't own. You need some verifiable proof as an anchor. The anchor needs to know that the address in question that Stellar, that the assets are being sent from and to, deposited, withdrawn, the account that we're dealing with needs to be verified as being owned by the one calling these endpoints. And the way we do that is through this WebAuth endpoint. I believe this is another SEP. I think it's SEP. Is it SEP-10? Yeah. Web authentication. So you can start to see a lot of these SEPs start to play together to create this interoperability. And this is why SEPs are so important and pivotal in the creation of Stellar applications. Is once you start to have this interoperability, all of these things, all of these SEPs, all of these methods for accomplishing similar tasks are all the same. They're all this singular way of accomplishing this goal. So this is the way. SEP-10 is the method by which you prove ownership over a specific Stellar account. So you would have to go through the SEP-10 docs here to identify how to actually prove that ownership. And I think it's covered a bit in, if we look at our SEP-24, let's go ahead and dive into our deposit. Actually, I think there's, the authentication. So you have to perform the authentication with SEP-10 because SEP-10 is going to be asking for an authentication JWT, JSON Web Token, to prove ownership for calls that we're about to make. So we're about to start doing some depositing and withdrawing, but before we're allowed to do that, we're going to need this JSON Web Token. So if we were to look down into our deposit here, not exactly sure where these pop up, but we'll get into it once we dive into the actual deposit flows. But essentially, when we're getting our authentication token, then this is definitely related, but it's also its own workshop, how to do the authentication for SEP-10. But essentially that TOML file has a web auth endpoint, which you call with a public key. You essentially say, hey, Mr. Web Auth endpoint, I would like to prove ownership over my account, over this public key that I'm about to use, which is this key right here. I want to prove to you that I do in fact own this key. Well, how do you do that? Well, you call the Web Auth endpoint and they say, cool, all right, you want to prove ownership? Well, to prove that ownership, you're going to need to sign a transaction. You're going to need to take this transaction that we're going to send you and sign it. So they're going to create a transaction for you and send it to you. Once you make this call, they're going to return a response which contains the transaction. And that transaction needs the signature of this public key that you've just said, hey, I want to prove that I in fact own this. So that's what we're going to do here. The transaction comes back after we make that request. And then we take our key pair, which is, again, we're going to decrypt our own key, which is stored. That's that encrypted key right here. It's the secret key, the key store file for this account. We're going to take that and generate the key pair and then sign that transaction that says, hey, I have now proven that I in fact own this public key. You can then send that signed transaction. It's not submitted to the network. It's sufficient just to prove that you do in fact own the account by having the signature, because only the secret key, this key pair for this public key, can actually sign that transaction. So you send that transaction signed back to the Web Auth endpoint in a post. So the first one is a get. I want to get the transaction to prove that I own this public key. I sign it and then send that back to the post endpoint. And assuming that that all goes through, they respond. This Web Auth endpoint responds with a token that you can now use for subsequent authentication requests. So that's going to be loaded into this token. Assuming all of this is successful, that authentication token is going to be stored in an auth variable, which we can then use when we're doing our deposit, which we're finally about to get into. So now we have successfully added a trust line, or we've either verified that we do in fact have a trust line already, or we've added a trust line, and now we've gotten the info about the anchor, and we've got a JSON web token, authentication token, proving that we own our public key, all fired up, ready to go to create our our deposit. And this piece here is where we get our first kind of request. We're basically making the request saying, I would like to make a deposit. I would like to interact with the SEP-24 server in making a deposit from my bank account to the anchor, and for them to exchange that into tokens for me to use on the network or do whatever I want with. And that's going to be returned. So that's that first deposit, basically just making the request to say, make this possible. And that's going to return a bunch of information. So coming back, let's start back up at the top and go to that post request interactive. It takes a bunch of information. Some of these are optional, depending on what kind of asset you're depositing and what information the anchor requires. You're going to provide that in the case of some form data. So we have our asset code, or an account, and then I have language here. But essentially, what currency do you want? And that's the SRT that we asked for. And where do you want it deposited? I want it deposited to this public key. And then we make that request, and you'll notice we have that authorization bearer auth token. So that's that JWT that we've called in our auth. We're using that to verify for this public key that we're making the request for deposit to. I do in fact own this. So somebody else isn't able to hijack and say, deposit this into an account that you haven't proven ownership over. And then that's going to return this response with a bunch of information around these shared both deposit and withdrawal. So deposit and withdrawal are very similar. So there's quite a bit of shared response and even request information, but type URL and ID. So if we actually were to make that request, let's actually return. Hopefully this doesn't break. My TypeScript's a bit picky about these kinds of things, so we'll see if that breaks. But I would like to, yeah, it's going to break. So let me comment the rest of this out just for a minute. My IDE doesn't like bad code. Imagine that. So let's go ahead and deposit an asset. This isn't going to get us super far. It's going to see that we don't have SRT. It's going to make the trust line for that SRT. So there we go. We've got a trust line issued. And if we start looking at our console, we can see some of these things start to come through. There's our JWT. There's the info. There's the transaction that we submitted to actually create the trust line. And now we've returned right here at the interactive console log. So ID, type, and URL, ID, type, and URL, just like the response said we would get. And that response is going to have all the information we need to continue moving forward with our deposit. So it's got an ID, which is just kind of information about the instance of this this particular interaction with the anchor. And then it's got a type. So this is kind of the state of this particular ID, this particular interaction. And it says interactive customer info needed. So the anchor's basically coming back to us and saying, hey, for this to work, we're going to need some more information. And that information can be found at this URL. So we're going to pop up this URL, which has, as we can see, the ID of that transaction, as well as the token for this transaction, all the information we need to be able to continue the flow. So right now our thing is stuck loading because we returned it. So we'll carry on to the next section. So now we've got all the information we need to carry on to the next section, which is to actually pop up the URL. This particular one, I think, is calling the transaction. So it's basically just looking at any existing transactions that we've already called. I don't necessarily think we need this one at this point. I think this is just proving that there is a transactions endpoint, which basically asks the question, was this call appear successful? Did we indeed create an instance of a pending deposit? Because if we return this, it should show so we'll start this back over again. And now that we've got our SRT, it should be a little bit quicker because we don't need to create that trust line. Trust line's already been made. It's going to get that JSON web token and return the transaction. So we can see that we do in fact have the ID with all the information around this particular deposit and that it is right now incomplete. So the next step is actually to create this URL where we're going to call a pop-up. Alrighty, very good. Well, we are back for our second half. Honestly, there's not a whole lot left to cover, so we'll spend a bit of time here on this last bit, making our deposit, and then cover the withdrawal flow. There's really only one piece left. So once we have gotten all the information from our anchor around their asset and are prepared to, as you recall, in our wallet here, we've gotten all the information necessary to this URL to call, which will pop up the information we need to continue the process of making our deposit. It's now time to actually create that pop-up. So there are several different ways to do that. You can obviously open it up in an iframe. You could send your users to a completely different tab. In my demo, I have chosen to use a pop-up window. So basically just opening up a new DOM instance, but in a pop-up. Not all browsers support pop-ups, so if there is no pop-up after you try and create it, you'll want to call that out or just use an interface that is more universally supported. Pop-ups are very well supported, but there are some limitations. So just be aware of that. So we're going to pull, if you look up our interactive, so we load up our interactive piece right in here, which has the information around the URL that we need to call. So we're going to call that interactive URL inside a URL builder, which we then set with a callback of post message, which I'll cover in a minute. And then we open that pop-up to the URL that we just set with a width and a height 500, 800. And that will open up the window. Now, this is where things start to get a little bit interesting. I'm going to go ahead and open that window up by saving this and reloading all this. We'll go ahead and pop that up, and you'll see, like we did at the very beginning, this window will pop up on the side. So this is our pop-up window, which loads in that URL that we called above with this callback of post message. So there's going to be, you're not going to really get a sense of it here because the Polaris demo walks through all of these things automatically, all the next steps type thing, but there can be, and there will be, a lot of time gaps in between these flows. So if you're making a deposit, it can take quite a bit of time for that deposit to actually go. So you're going to like trigger the deposit and saying, hey, I would like this anchor to give me 500 coins, 500 US dollar tokens, but the anchor is not going to do that until they've received 500 US dollars from your bank account, right? Till you've sent them by wire transfer or ACH payment that 500 tokens. So there's going to be a time gap there, and there are different ways to get around, like that can be a problem, right? So the window pops up, but most likely people aren't going to have this window just open for 7 days while the deposit clears. So in our demo here, that interaction of having money get sent from your bank to the anchor, from the anchor to your wallet, that's not all going to happen all at once. So there's going to be different ways to handle like the callbacks, the triggers that say, hey, we received some money, it's ready to go into your account, then the next step is prepared. There are several different ways to take care of that, and that would all be in that the callback method. So there's 3 different ways to kind of check the status of a transaction. That's why you have that transaction ID. One of those is to just ping the get transaction by ID. So if we look at that, we pass it the ID or the stellar transaction or the external transaction. Like it's going to need some ID to look it up. So you basically look up that transaction. You say, what state are we in? Particularly if it's a very long running deposit. In our case, that all happens is simulated automatically through the Polaris interface. So we can use this pop-up window with the post message API, which essentially says it opens up a connection between this tab here and this window here, where they can communicate between each other through the post message API. So if you just, you can find all of the post message API syntax for how to send messages back and forth. This API or this SEP-24 allows for the post message callback. So there's just pinging transaction endpoint to get the status. So when a user like, oh, it's going to take 7 days. So 7 days later, 5 days later, they come back to the wallet and they say, hey, I wonder what the status of my deposit is. You can look up that transaction and it'll give you back the information in the status key here, what state the pending transaction is in. When everything is happening very quickly, maybe with a crypto anchor, where it's not going to take all that long for a deposit to happen, kind of like in a Changelly or Uniswap type flow where the time's not going to be all that long. You might choose to use this post message option, which will open up 2 tabs, and then those tabs can communicate and provide real-time feedback between each other, sending messages between those 2 open windows. And the third option, if we look up our callback let me just search. Yeah, callback details. You have the option to also give it a URL, which will post a JSON message after the user's completed the interactive flow. So you can also, so it's almost like a webhook where you essentially set up a URL that says, hey, once the next step's been completed, send a JSON message via post to this endpoint. And you'll set up a webhook which will receive that and then can send your user an email address or an SMS or give them a push notification that says, hey, such and such has happened. It's time to complete the next step, or see your money in your wallet or whatever. So we're using post message by setting up the callback to post message, and then we're going to throw the pop-up via open. Pop-up is supported in Chrome, so we're not going to have that message thrown. And then we set up on our window, which is this guy right here. Once a message is being sent from the anchor, once the post message is being sent from the anchor to our wallet, we will intercept. Oops, looks like I closed my code somehow. We'll intercept that message and grab the transaction details. So this is actually the same information that would come from our transactions here. So when the transactions are called, or I'm sorry, when transaction, I guess we're not calling it, but if you were to call the get endpoint on an individual singular transaction, the same information is returned on the on message inside the data transaction attribute, so we can look up the status. And in this case, if the status is completed, we'll update the account. So that's basically saying once the whole thing is done, the money's been deposited, we'll set completed. Otherwise, if it's not completed yet, we're going to set a timeout and we're going to call the message again. Basically, just keep pinging the anchor service, just keep pinging this until the flow has been finished. And so no messages are being sent back at this moment, so nothing's been triggered yet. We're still waiting, in this case, for some kind of dummy KYC information. So I'm just going to fill out some dummy KYC information and then submit. So that's going to take it to the next step, which is going to ask us, it's basically going to do a confirmation, basically verifying your email address to make sure you actually have ownership over your email. We'll skip that. And now it's asking how much do we want to deposit. So all of this is happening separate from our code. It's all inside the Polaris code base with this little modal window from that URL that we called. And we're going to deposit a nice fat stack of 10,000 SRT. We can see it's got a little bit of a fee right here that'll be charged, delivering a final 9,998 SRT. So we'll go ahead and submit that. And then that loop starts, and you can see it triggering right here where it keeps looping over, calling this until the deposit is completed. Now it's very, very quick. I'm very handy on my phone. I was able to go to my SRT bank account and quickly send them 10,000 SRT, which Polaris then received and turned into 10,000 tokens. It took 2 of those out as its fee and then deposited in my account 9,998 SRT. So we are now the proud owner of that many SRT tokens, which is fantastic. We've just completed our deposit with SEP-24, and just like that, with just a few lines of JavaScript, we are easily able to interact with not just the Polaris API to allow us to deposit SRT into our account, but because of SEP-24, because it's a SEP, and any anchor will use this same SEP-24 flow, any anchor out there that implements this SEP, you will be able to automatically, with this exact same code, implement with their anchor service. So all you would have to do is create a list of home domains from which to look up the TOML files for these different services. So Anchor USD and Settle and other anchors in the Stellar network, you would say, these are the entities which I would like to allow my users to interact with deposit and withdraw. And then they can very easily begin to deposit and withdraw those assets, all using this very simple flow that we just went through, with the exception of if it's long-standing deposits, you might want to switch from an on message or this post message API to either a ping where you just call the transaction endpoint, or that webhook callback, post callback. But there's a couple of different ways to interact with that, and you just have to decide which one fits the anchors that you're using. And it may be a different one depending on which anchor. Like, hey, if this is a crypto anchor, use post message. If it is the United States and it's going to take multiple days, we'll just use the ping transaction endpoint. If it's relatively short, we might use a webhook. I mean, depends on what your flow is and what anchors you're connecting to. But the main thing to draw away from this is because we're using the SEP-24, with the same code base, we can interact with all of these different transfer servers, which is pretty incredible and makes a wallet's life much, much easier. However, at this point, of course, we've only got our deposit. Now we need to kind of invert the flow and go in the opposite direction, which is withdraw assets. And there's not a whole lot that's different here. Really, the only thing that's changing is kind of going in reverse. We're taking the money that's in our Stellar account, and instead of paying from our bank account to the anchor to the wallet, we're going from the wallet. The wallet pays the anchor, and the anchor will deposit money into your bank account. So we essentially just do the thing reverse. And not like once this asset exists in our wallet, like it exists everywhere that wallet is accessible. So if we were to go back to our wallet here, we'll notice that we have that SRT in our account now. So we can use that SRT to pay other other accounts who have an SRT trust line opened. So we can make payments between other wallets. We could put up offers on the order book for SRT to XLM or USD or any other asset to create order books where we could try and turn a profit or just facilitate path payments or provide liquidity. It's a Stellar asset now. So anywhere that Stellar touches, you're able to move that asset in as well. This does come with some caveats around the issuer of this asset and how they've set up the functionality for this asset to be used. So there's some things like auth required and some other functionalities that limit how an asset can be used. And this is very important for things like regulated assets or ensuring that your asset is only used underneath particular parameters, either for legal liability or other reasons. So as an anchor service or as an asset issuer, there are some flags that you can set that limit how an asset can be used. But by default, this asset is treated in exactly the same way that even our own XLM token, the native asset on the system, is used. It's really not any different. It has an issuer. It can be moved around. It can be used as payments. You can do offers. All the things that you can do with XLM, you can do in this case now with SRT, which is fantastic and actually quite different from the way that like an Ethereum model would work, where assets are not first-class citizens and they kind of exist within their own individual smart contract ecosystems and have a lot more stringent controls on how that asset can be used. Within Stellar, assets are first-class citizens and can be moved about in a very native, fluent way that's very easy to understand and native to the system, which is fantastic. But anyway, this SRT is going to be moved around, right? You might make payments. You're going to do some path payments. You're going to make swaps. You're going to put them in order books. But at the end of the day, you're going to maybe want to, or somebody, you or somebody else is going to want to take this SRT and go buy groceries with it, right? They need to convert this. And if your grocery store does not accept SRT from the Stellar network yet, or you just need some cash on hand, you are going to need to interact kind of in reverse with this anchor where this SRT gets deposited into a bank account. Or maybe in the case of a crypto anchor, back into the Bitcoin network or the Ethereum network or the Tron network, BAT network. There's lots of crypto anchors out there too, which allow this interoperability between networks, which is actually kind of cool that's possible. But primarily this is used right now for fiat anchors. And for obvious reasons. It allows a lot more agility to your fiat, where it can be used anywhere that Stellar is running. But eventually, yeah, it's going to end up in your account and you're going to need to withdraw it. So we're going to be doing this deposit flow in reverse with withdraw. So a lot of this is going to seem replicate because it is. We're going to kind of go through, look at the balance, if we have the currency, blah, blah, blah. Look up the info for that, get another auth token so that we can verify that we own this account. It can actually do the withdraw for this. Set up our form data, which includes the asset code and account for this interactive withdraw. So this is going to give us that same thing, but in this case, instead of a modal or a pop-up window for a deposit, for a deposit, it's going to be for withdrawing. So the interface is going to look a little different for this particular endpoint. And then we can also get the transactions, which I think I accidentally removed. Just want to make sure we don't get in trouble for my IDE not using this. Look up all our transactions for that. Again, we're not really using this one at the moment, but it allows you to verify that in fact there is a pending interactive withdraw on for this public key. And then we do the URL builder again, which creates the pop-up. And then it will open that pop-up unless they are not available for this browser. And then this one actually is a little bit bigger and different because we're actually going to be making a Stellar transaction. So in the case of the deposit, the actual deposit is being simulated on Polaris's side, where I kind of pretended like I used my phone to, go to my SRT bank account and move money around. Well, when you're inverted that and you're actually moving SRT to the anchor, you actually need to make that payment because that's outside the anchor's control. That's in your control. You actually need to say, if I want to withdraw 998 SRT into my bank account, I need to make a Stellar payment to the anchor for that amount. So for that reason, we're adding a little bit of additional logic here on this end to allow for for Stellar to create a transaction to make that payment. And that information for where that transaction needs to go actually comes from, if we look at our destination here, the transaction information on the on message. So let's go ahead and start this flow. I'm going to clear this real quick. The flow is basically asking the question, how much do you want to withdraw? And we're going to fake in some bank account details. So let's say I want to withdraw 998. I'm actually going to put in a pause here. We'll leave that one. We'll put the pause right here. So this is before we actually make the payment. I think this will work. We might get in trouble with this guy, but I'm going to do we do a resolve? I'm going to go ahead and just console log the transaction so we can inspect. Oh, I guess we're doing that up here. So let's actually keep all this and just try to return for a minute after this console log, and then block out all this stuff. Might get in trouble for that, but we'll see. So that we can inspect the transaction that's coming back. So once I actually submit this information, it's going to send a message back to the browser that gives information about the state and what's next for this withdraw sequence. So let's go ahead and trigger that. Oops. So we're going to withdraw 998 just so it's clean. Nobody copy my bank account information, please. Thank you. There's a fee, a little bit of a fee. And we're going to wait on the user to transfer funds. That's our status. And we get back pending user transfer start as the status. And the information that comes back is all the information around how much we need, what the fee is, how much we need to pay in the amount in right here. That's how much is being paid. And then also the address that we need to pay to. So the withdraw anchor account address. So that's the Stellar account that we need to actually send this 998 lumens to. And so since we have all that information in the demo here, we're going ahead and just doing that. So if the status is pending user transfer start and it has not been submitted yet, we don't want to accidentally pay multiple times. If we haven't submitted the transaction yet, we're going to go ahead and do that. We're going to load in our key pair, so our public key here, and we're about to make a payment. So we take the account, create a transaction, queue up a transaction, and then add an operation with a payment to the withdraw anchor account. So it's this guy right here. And we do it for transaction amount in, so that 998 lumens. And we do it in the asset that we set when we initially selected which asset we wanted to withdraw, that SRT. So we've seen that before. And then we add a memo, which basically just marks this transaction, marks the transaction so that it's traceable in the system in case anything goes wrong or has to be double checked on or just for logging reasons. We sign that transaction with our key pair from before when we unlocked, I think we do it up here, right? Yeah, when we decrypt the account. So we sign it and then we submit that transaction, which will make that 998 SRT payment to the anchor. Now, once the anchor, like we're continuously pinging that window, right? After we make this payment, we queue up to recall that window, which is then going to go back to the window and say, okay, window, we just made our payment. Can you check the blockchain? See if that payment's been made. And then the window's going to load. It's going to say, hey, we have checked. And either yes, it has, or no, it hasn't been made. And it will keep going back continuously in this case to continuously look. And this is another one of those instances where it probably is fine to use post message because Stellar transactions are very quick. But if the anchor for some reason wants to double check or verify or make sure you're qualified to receive the payments in your account, if they have to do any sort of long format like 24-hour wait period withdrawals, you may not want to use post message. You could do the callback, or you could use the transaction pinging, where you just ping the transaction ID, or do the webhook on the post endpoint. But in this case, our Polaris anchor is very quick, very speedy and responsive. So we'll use post message and it will eventually come back with, hey, we found your transaction on the Stellar network. We see that you've paid us 998. So we will move that money into your bank account. Now I don't actually have an SRT bank account, so we can't look that up and prove to you that the anchor did in fact deposit that into my bank account. But that's the whole idea, that what would happen when an anchor receives your Stellar tokens, they would burn those tokens and give you your 998 SRT into your SRT bank account. So let's go ahead and go through, make sure I've saved this so we don't hijack it in the middle. Refresh this and see if we can get through the whole withdrawal flow. You'll see the logs coming in down here. I'm going to go ahead and clear that so we have a nice fresh log. We're going to withdraw those, put in my bank account details, and hit continue. So that's going to come back here. A transaction is going to be made to the Stellar network for those 998 lumens. We'll see that goes through. Our SRTs decreased to 9,000, and this has been completed. The fee has been removed. That 998 minus the fee will end up in our SRT bank account, just like that. Magic. So now we have gone fully from depositing to withdrawing. It's a wonderful Stellar world. And because we've used that SEP flow, any anchor out there that's implementing SEP-24, any entity that you can find with that Stellar TOML file, right, that has this SEP-24 server, this transfer server SEP-24 endpoint, you should be able to do all of what I've just showed you for whatever currencies that they support. So there are quite a few anchors out there. We're constantly looking for more. If you're looking to set up a Polaris endpoint or an anchor endpoint, the Polaris open source project is a great place to get started. If you're just looking to implement anchor services into your wallets or financial services, especially if you're trying to gain access to stablecoins, SEP-24 is the place to go. And if you're looking to make those just payments from one entity to another through an anchor, and you don't necessarily need all of these functions and features for depositing, withdrawing, you just need all that to happen automatically. As Jake mentioned earlier, you can just use SEP-31 for that. That's really honestly the content of the whole thing. So let's open it up for some questions, some discussion. We'll try and add a little bit of friendly vibes to this otherwise a bit monotone workshop. If anybody would like to jump on, ask questions, or even just discuss what you're working on, that would be fantastic. Otherwise, we get to look at me for 15 minutes and don't really want that, do you? So I'm going to stop screen sharing and we can just open it up for chats. Jake, anything to add? I don't know if you're still there. Jake's the man with the plan behind Polaris. I also assume you've been heavily involved in SEP-31, perhaps?
Yeah, nothing to add. Polaris is actually for SEP-24, but it's also for SEP-31 as well. We're building out SEP-31 support in there as well. So it's kind of becoming a one-stop shop for a bunch of transfer SEPs. But yeah, no, great video.
Very nice, cool. Yeah, the Polaris endpoint is amazing because it makes these kinds of things easy to test and set up and integrate within a wallet. So I would highly suggest anybody that's trying to build out these types of services into your application. I mean, I think it's way too often that I see fintech apps just assume crypto and assume accepting or making payments in crypto. But for this to get mass adoption, we really need to look at implementing fiat tokens. And really the only way to do that is if we have on and off ramps. And really the only way we can implement those on and off ramps is if we have a way to test them. So having Polaris available, easy to use, works well, is fantastic. So I personally really appreciate the work that Jake has done in building that out and continuing to build out things like SEP-31 as well to make these things easy to implement, to encourage and enable folks to move beyond just crypto tokens and begin to use real world fiat currencies that the world in general, the world at large, is more comfortable and used to.
Right. I mean, everything that we run, the SDF runs, is open source and available on GitHub. So if you want to see the code that's actually running on the server that Tyler was using to test with, then it's there. So if you want to look at how an Anchor server is actually run instead of looking at the wallet side of things, then it's there as well. And if you want to build your own Anchor, we have documentation to use Polaris as well as if you wanted to do your own thing and build your own Anchor server.
Yeah, fantastic. Very cool. Any other questions, follow-up, projects that folks are working on that they'd like to call out or ask questions on? Now is your time to shine, to plug whatever you're working on. Would love to hear what folks are doing. Will the source from this exercise you just walked us through be shared? Yes. So I think it's going to be the source code. Yeah, it looks like it was just shared there, the Stellar demo wallet. There's a couple different branches. The master branch is what we were working from today. And the documents, there are some really good, might have been a little self-serving since I wrote them. I'm trying to bring it up here so I can share it in chat. Hold on one second. I have a walkthrough that goes through both what I talked about today with the code on the wallet, as well as kind of the precursor to that, actually getting up to the point where you can do SEP-24 implementation. So I just shared that in the chat. Jake, do you want to talk a little bit about, we got a question here. Has Polaris had an outside security audit? Not that I don't think it's of excellent quality.
Yeah, that's a good question. It's been talked about, but no, we haven't done that yet. I think that is probably something that we want to do. The question though is that, is this something that the SDF should do, or should, the developers using Polaris get audited and assess, you know what I mean? It's kind of like
it's a good question. And it's almost less about, we should, and more about like, should we, like where's that? Like, it becomes really difficult because there's so many different jurisdictions and so many of these rules are still being written and decided, and the best person to determine those things and actually do an audit or spearhead the effort in doing an audit would be the implementer of the code. So this is more, here's a great place to get started with the programming of the thing, because there's two very distinct things at play here. There's the actual code for making these things possible, but then there's also the regulatory side. And we provide open source code for the technical side, but from a regulatory standpoint, that's not what the SDF is built to do, to audit or to maintain sort of a regulatory compliant, because it's always changing, and there's just so many aspects and avenues that are different for every jurisdiction, and the person that's going to best understand that or be able to answer those questions would be the entities that are actually implementing that. So that's kind of, it's a difficult place to stand, I think, to make those decisions. And while it would be amazing, it can be dangerous.
Yeah, and Polaris could be secure, but it is a framework. So if the person, if the company or organization using Polaris has a vulnerability outside of the Polaris code, so I think the person using Polaris should make sure that their software, Polaris included, is secure.
Right. Yeah, you're gonna have to do so much licensing and KYC, AML for yourself before you can even sort of generate or run legally an Anchor service, that you're going to need to get audited, even if Polaris itself was secure. Like, the code itself could be licensed or very secure in itself, but how you implement it and really the jurisdiction that you're operating it in, kind of, those are two separate questions anyway.
Right.
That's helpful. Is there a dedicated Keybase or other forum for questions on getting a Polaris instance up and running?
I spelled that wrong, but it's dev discussion. That's kind of the general area that people are talking about, building stuff on Stellar. There isn't a Polaris specific channel though yet. We haven't gotten the kind of traffic that would warrant that, but it could be created.
Yeah, dev discussion is going to be your best place for getting started on stuff like that. And then as you get closer to execution or have more specific questions, you can reach out to Jake's team directly, or create pull requests or emails within the Polaris.
Yeah. And I think it's important to mention too that Polaris is a Python tool, so if you're using Node or you're using, you have another language that you're really comfortable with, I would just build your own anchor from scratch. Polaris is used to do most of the work, and then you kind of plug in your custom stuff that only the anchor is able to actually do. So like, the integration with your bank. But again, if you don't know Python, you're probably better off, or you don't know Django because it uses Django as well. You're probably better off, building your own service instead of trying to use a tool, that you're not familiar with, or you're not familiar with the language it's written in.
Yep. Yeah. We had a question about a Node Polaris the other day, but I don't know. Python's good, and it's not too hard to go from that to, if you need to, build out a Node version of it. But the whole point of having an open source anchor is not necessarily so you can, get an anchor up and running in 30 minutes flat, right? There's a lot of other steps to actually setting up an anchor service besides just getting the infrastructure running. There's legal compliance issues and usability concerns, and you have to have a whole marketing concept for how are you going to get this token used, because just because you have a token out there doesn't mean it's going to get used, particularly if you haven't done a lot of the legwork to ensure that it's secure and provable and has good traction already. But it's a business model. It's not like a plug and play thing that you add on top of a business. Like, it may be part of your business, but it definitely is a business in of itself. Good questions, though. Anything else? What's the best place to reach stellar development community? Keybase is really good. That's the best place to ask just general questions. Galactic Talk is a really good one to get like longer format questions. Also, I mentioned earlier, I'm in charge of running a community fund at Stellar, where every 3 months we split a pool of 3 million lumens between 8 different projects. So I'm going to put that in chat real quick. So as you guys are building out things and have ideas for stuff and have pitches to the community, the Stellar Community Fund is a good place to get kind of seed fund money for your project, as well as community feedback around the usability and security concerns around whatever you're building. The money's nice, but most of our projects appreciate the community aspect more, where there's just a lot of marketing that goes on around the projects that are being highlighted, and lots of community effort around reviewing and testing and generating a little bit of excitement. It's not free marketing; you still have to do work. But if you do your job and work hard and have a good project, the Stellar Community Fund is a great place to get some traction for whatever it is you're building. And then for like partnerships, as far as, getting community help developing, if you're looking for somebody to hire, Keybase is, again, a really good place to the dev discussion channel to talk to developers and start to integrate into the community itself. We also have our subreddit, r Stellar, where lots of discussion. We have a nice daily chat there. Lots of news gets posted there where people can comment. It's a good place to find active community members. So it would be a place I'd like to call out. All right. Thanks everybody so much. Jake, really appreciate you coming out to chime in. That was appreciated. Big claps to Christine and Anka for putting this on, organizing it, pushing for the socials to get the word out. And we'll see y'all in the future. Thanks so much for jumping in, tuning in, and we'll see you around. Bye.